Here's problem 28.6. In the figure, if R is equal to 11 ohms, what is the equivalent resistance between points A and B? Now recognize, as we look at this figure, that if we have a wire that connects 2 points and there's no resistance or battery or any other element in that wire, then it's essentially connecting 2 points of equal voltage. So it's almost as if those points were connected. For instance, this wire right here is connecting this point to this point, and they're at the same voltage. There's no voltage drop there, so we might as well just connect those 2 points together. Same thing here, and same thing here. You can add and subtract wire if there's no circuit element there. So this circuit essentially looks like this. We have point A coming out here to resistance R, and then that's connected in parallel with a 2R, and then we have this points that we just connected together, and then we have a 3R here, and then down below we have a 4R, and then we come out to point B. So as we look at that way, it's pretty clear that what resistances are in parallel and what branches are in series. So now as we look at this, we have a R in parallel with a 2R, and we have a 3R in parallel with a 4R. So if we calculate those parallel resistances, for the first one, R parallel will be equal to, since there's only 2 of them, it'll be product over the sum. So it'll be R times 2R over R plus 2R, and that will be equal to 2R squared over 3R, and get rid of one of the R's. So this is equal to 2/3 R. And then for the other R parallel, call it R parallel prime, we'll have a 3R product with a 4R over the sum, which will be 3R plus 4R, and that's going to give us 12R squared over 7R, and again get rid of one of the R's, and that'll give us 12/7 R. So now our circuit looks like this. We have point A, we have a resistance here of 2/3 R, and then we have a resistance over here of 12/7 R, and then we get to point B. Okay, now it's clear that these two resistances are in series, so we can add them together. And so now our total equivalent resistance is going to be 2/3 R plus 12/7 R. And if I calculate that out, see, 2/3 plus 12/7 is 2.38 R. Now in the problem, R is equal to 11 ohms, so this is 2.38 times 11 ohms, and that will give us an equivalent resistance of 26.2 ohms. So that is the equivalent resistance of our circuit. We can write it just as one resistance between A and B, and that would be 26.2 ohms. That is our answer.